All right, if you'll start working through these 4 problems that we have here, these are the fractional exponents that we talked about last time. So just take a few minutes and start working through these 4 questions. All right, just a few reminders and announcements. So today is the second to last day of class, right? So this is going to be actually the last day that we'll have new content to learn. And then on Thursday, we're going to use that day to do reviewing for the final exam. And then on Friday, if you would like another review session, then I was going to hold one on Friday as well, but I wanted to get some feedback from you guys today on what time on Friday would be good for you. It would need to be like 1 o'clock or later for me, but I just wanted to try and see if there was a good time for more people to be able to attend it, or if we're going to need to do that. So actually I'll ask you on Thursday. We'll see how far we get as far as the reviewing goes on Thursday, and then we can kind of discuss at the end of class if you want some more time for review. Okay, so last time we talked about these. So these are fractional exponents, sometimes called rational exponents. And these are what kind of the new thing was from last time. So let's just look through a few of these and make sure that everybody is remembering what to do with these. So remember, you're going to still use those property of exponents just like we have in the past, but now they just happen to be fractions. So we have to make sure that we remember to follow our fraction rules also. All right, so on this one, when they're connected by multiplication, which these are, let's see if I put like a little multiplication dot in between there. All right, so these are connected by multiplication. Then we're going to add those exponents together. So we're really doing x to the 3/2 plus 5/2. And since we already have a common denominator, that's great. We'll have x to the 8/2, but then 8 divided by 2 is 4. So x to the 4th would be our answer on that one. All right, on this one, well, actually, I guess I'll go down here to B. We'll do it in order. So on part B, we've got a power raised to a power. So remember, that's multiplication. And so we have y to the 5/3 power times 4 over 1. All right, and then we'll just multiply across the top, multiply across the bottom. So it will give us y to the 20 over 3 power. And that won't reduce anymore. So that would be our answer there. Okay. On this one, we have a negative exponent on part C. So remember, when we have negative exponents, we need to flip those upstairs. So all of this, right, is unhappy down there and is going to flip upstairs. So that means we'll have x to the 3rd times x to the 1/2 now. Right? It's no longer negative because we flipped it upstairs. And now, again, since we're connected by multiplication like we were on part A, we need to add those exponents together, but we've got to get a common denominator first. All right, so to get a common denominator, 2 is going to be our common denominator. So we'll multiply this first one by 2, so that will give us x to the 6 over 2 power. All right, 6 over 2 reduces to be 3, but we need it for a common denominator there. And then plus 1/2, so x to the 7/2 would be our answer on that one. All right, and then this last one has quite a few things with it. All right, so let's just take it one step at a time. Remember last time I said sometimes, you know, some of these questions can feel a little overwhelming because there's a lot of steps to do on it, but just focus one at a time. So the first thing I'm looking to do is I'm going to distribute that 6 on the top. So when I do that, I get x to the 2/3 times 6 over 1. Right? And then I also have y to the 2nd times 6. Right? And then the bottom, right, I could flip that x upstairs right now too because it's negative. So I'm going to go ahead and flip that x upstairs. It was x to the -1. Now it will be x to the +1. And then on the bottom I have y to the 1/2 times y to the 3/2. Okay. Scroll down just a little bit here. And then let's just kind of combine some things together. So up on the top, right, if I get this, you know, figured out, so 2 times 6 is 12 divided by 3 is going to give me 4. All right, so I have x to the 4th, and then y to the 12th, and then times x. All right, and then on the bottom, when I get those y's together, remember they're connected by multiplication, so again, I'm adding those exponents. So that would be y to the 1/2 plus 3/2, which is going to be 4/2, all right, which is going to simplify to be y to the 2nd power. And we'll do that on the next step. Let's do one more thing here. So if I get my x's together on the top, I'll have x to the 5th, and then remember I said, maybe I'll just change it right here. Remember that 4 divided by 2 is just going to be 2, so it's going to be y to the 2nd power. So I've got y to the 12 on the top, y to the 2nd on the bottom, and so there's 10 more on the top than there are on the bottom, so y to the 10th would be our answer there. And then there's nothing left on the bottom, so that would be our answer. Okay. All right, any questions that you had on those 4? Clarifying anything with these properties of exponents that we talked about last time? Nothing? All right. Well, let's move on to other stuff then that we need to talk about today. And some of the stuff that we're going to be talking about today will be new, and some of it will be review. Okay, but I want to talk a little bit about, so if you, let's see, this should be on page like 161 or something. So look and see. Write that up here. So look in your book on page 161. At least I think that's what it is. If it's something different, if somebody will type it into the chat and let us know, that'd be great. Okay. So we're talking about, we've seen these different types of equations before. And when we talked about these equations, we talked about solving them, we've talked about graphing them. And so we want to just kind of look at them, look at the structure of them, and be able to tell a few things about them in order to recognize them. And that's going to help you on the test, like on the final exam, because you might get something like, you know, one of these equations and it might just say solve. And so you've got to think about what are you doing there when you're trying to solve something like these. Okay. So first off, let's write down the type of equations these are. So remember we said when something is to the second power, right? We have all of this raised to the second power. We said that's a quadratic, right? And sometimes it looks, you know, like it's in standard form, right? It would be ax squared plus bx plus c equals 0. Right, so it would be quadratic, but this is in that complete the square form, right, in that vertex form, which is making it easier to find that vertex. So this is still a quadratic. Okay, so let's just put that in here. This is a quadratic. Right, the second one, right, so if we have this root on here, right, and we skipped over in the book, there were supposed to be some things about different roots besides square roots, but you'll get to those more in 1050, and so I didn't want to bog you down with more information and stuff with things that you'll get to in 1050 anyway, so we kind of skipped over them. So these are just square roots, right? So when you see that, this is a square root. This is the type. Right, now notice this one, right, we have 2 to the something power equals 2 to the something power. So when we have these powers like that, that is exponential, but let's be a little bit more specific because we'll notice on this one that we do have the same bases. And the way that we solve those when they have the same bases are a little bit different, right? So let's say exponential with like bases. Okay. And then the next one, right, is also exponential, but now they don't have like bases, right? So exponential with unlike bases. Okay. And then the last one is going to be a log, right? A logarithm. All right, so kind of noticing what these are, understanding what they are, is going to help us to figure out how to solve each of these. Okay, so let's look at this quadratic here, right? And with the way it's set up, oh, thanks, Braxton. You said it's on page 164. Okay. Thank you. So, so can somebody tell me, how would you go about solving something like this top equation? What would we need to do there to solve this? Come on, we've talked about it. What would we do?
Could you set one equal to 5 and then the other one equal to -5 and solve?
So think about this squared, right? How do we undo squaring something?
Oh yeah, that makes sense.
Right? So how do we do it?
Do you divide the square root?
Yeah, we'll take the square root of both sides, right? So always think to yourself, like, how is this being connected? So that's like the biggest thing with solving, because you're going to see, we're going to talk about a bunch of different types of equations today. And so you're going to keep asking yourself, okay, how can I get that x by itself? What is keeping it there? Well, first thing is it's all inside this squared. So we'd either have to like FOIL it out, you know, and go that method, but that's going to be a harder way to go. In this form, since this side is already squared, we would just take the square root of both sides, right, and solve it here. So our key technique here is that square root property, right? So square root both sides. Okay, that's that square root property that we talked about before. Okay, and then I'm just going to take this over here and let's just solve this. You might have some room here to the side, or my marker is just kind of fatter in there to try and fit and make it legible. All right, so if I have something like this, like you said, we're going to take the square root of both sides, and we do that because the square root and the square will cancel each other out, right? And then we're just left with x plus 3 equals plus or minus the square root of 5. Right, and then to solve it, all we have to do now is just subtract the 3 over. All right, and we'll put it in front of that plus or minus sign. So x equals -3 plus or minus the square root of 5. Okay. All right, so I want you to practice on some of these that we're talking about here. I really want you to think, right, because that's what you're going to have to do on the test. What kind of equation do I have here? How do I undo all of that so that I can get the x by itself? Okay. And you'll notice these are kind of similar to each other. And, you know, that's done, you know, with a purpose to try and help you see some of the similarities when we're going through these. All right, what about this second one down? So it's a square root, right? And we just got done saying, you know, the way to undo something that's squared is to square root it. So on this one, the way to undo something that's square rooted is going to be to square both sides, right? So I will square this side and square this side. Okay, so my key technique here is just to square both sides. Okay, so make sure you really see the difference, right? Sometimes people will say square both sides when they really mean square root both sides. Remember that they're two, like they're the opposite thing. That's like saying, you know, you need to like multiply something when actually you need to divide it. Okay, so make sure that you're being really specific. Do you need to square both sides? Do you need to square root both sides? Okay, so here when we do that, let's go ahead and write this one down. So this time we've got the square root of x plus 3 equals 5. So then again, on this one, I'll square both sides. All right, and then that will give me the square root and the square undo each other, so that leaves me with x plus 3 equals 25. All right, and now to get x by itself, I just need to subtract the 3 over. All right, so you're just thinking, how can I get this x, right, to be by itself there? Okay, so square both sides on this one. All right, how about this next one? So we've got an exponential with like bases. what did we say we would do there? How would we solve something like this if our bases on exponentials were the same? Anybody remember? Brain's feeling overloaded. Like, oh, it's the end of the semester. I'm just trying to get through. All right, remember we said when the bases are the same, we can set the exponents equal to each other. Okay, so our key technique on this one would be to set exponents equal to each other. Right, so if our bases are the same, then we can put this side of the exponent equal to that side. Okay, so if I do that over here, that's just going to be, so I'd have 2 to the x plus 3 power equals 2 to the 5th power. So I'm just going to take the exponent parts and set them equal to each other. So I have x plus 3 equals 5. And then all I have left to do there is to subtract the 3 over, so x equals 2. Okay. Questions so far on these? Okay, what about our next one, that exponential, and they don't have like bases, right? So the bases are unlike. Well, that's when we said we had to use logarithms to solve it, right? We have to take the log of both sides in order to bring that exponential down in front, okay? So let's say, so our key thing here, right, is that we're going to take the log of both sides. All right, so I'll try and write in here so you can see. So we'll do log and then log. But again, that's just hard to read over there. There's a lot of room for me, so let me rewrite it here. So it was 2 times, or sorry, 2 to the x plus, looking at that going, that was so hard to read. I'm going to actually, just going to get rid of that for a second. Let's do, try and write it this way. So 2 to the x plus 3 power equals 5. All right, so this is where we'd say, okay, the bases are not the same. I can't get them to be the same. So the only way I have to solve them is to undo that exponential, and undoing exponentials is taking the log. So I'll take the log of both sides, right? Which now brings that x plus 3 down in front. Right? So I really have this. So I have x plus 3, put that in parentheses, because all of that is multiplied by log of 2 equals the log of 5. And now, again, I'm trying to get x by itself. So first thing I want to do, let's get rid of that other log that's connected there. So let's divide both sides by log of 2. Okay. And then at this point, right, we can put it into your calculator and kind of see what you come up with, and you'll want to keep that in your calculator. I'll write it down here. So we have x plus 3 equals the log of 5 over the log of 2. Okay, and more often than not, they're going to ask for a decimal approximation on this. So let's just plan on rounding our answer on this to the nearest tenth. So if I do the log of 5 divided by the log of 2, all right, I get this 2.2 3, 2, 1, 9, blah, 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 blah. But I'm not going to write that all down. It's never ending, non-repeating. It keeps going further than, you know, I can even see the numbers on my screen. So I'm going to keep that in there. And then to get x by itself now, right, I'm going to need to subtract that 3 over. So I'm going to take my log of 5 divided by 2 and subtract my 3. Right. And again, I'm going to round it to the nearest tenth. So that's going to give me negative 0.7. That's what I come up with there. All right, what things can I help you understand better? I know we have one more here, but I just want to make sure we're good so far. Okay, so let's take a look at this last one. So if you were asked to solve this, what would you do? What would you need to do first in order to solve that? What do we do with logs? I want to hear from somebody. I want to know that you guys are with me, you're thinking about what I'm saying. We need to do there. It's okay just to say something, you know.
Is it the same as what we did with the exponential one, with the log?
Kind of.
Do it that way?
Yeah, so you got to think about how logs and exponentials undo each other, right? And so it's in log form right now, so I'd want to change it to exponential form. Remember how we did that with logs? We said sometimes it's going to be easier to deal with logs if it's in exponential form. All right, so let's just put that down. So our key technique here is going to be to change log form to exponential form. Okay, so our log form, let me write this question out again over here. So log base 7 of x plus 3 equals 5. And then remember to change to exponential form, we said we'll do the base raised to this power, right, equals whatever's in that parenthesis there. Okay. So that will be 7 to the 5th power equals x plus 3. All right, well, 7 to the 5th power is going to be kind of a big number. So let's see, so that's 16,807 equals x plus 3. And then to get x by itself, I just need to subtract the 3 over. Okay, so 16,804 is what x would be on this one. Okay, so whenever you have a log in a question and asks you to solve it, a lot of times I would say especially on the final exam, since it just seems like there's so much on there to try and do, if ever you see something that's in log form and it tells you to solve it, right, the technique that you want to try here is try and change that log form to exponential form, and usually you'll be like, oh yeah, I can totally solve that. Right? You look at it at this point and you're like, yeah, that's not so bad to solve. But sometimes it just is easy to get stuck and go, what do I do with this log? Right? But remembering that logs and exponentials undo each other will be really helpful to keep in mind there. All right. Speak up if you have a question, please. Somebody else has the same question, I'm sure, in the class. Okay, well, I want you guys then to try these next three. Okay, we just talked about how to solve some of these types of problems up above. All right, key techniques there. So I'm going to give you a couple minutes and I want you to try and solve these three. Okay, when you have an answer for those three, will you click on your hand raise button so I can see where you guys are at? Remember, you'll have to open that participants window to find the hand raise button. So you'll have to kind of, you know, like hover over the top of your screen and you'll see a drop down. And then you'll see the participants. Click on that and open up that window so that you can find that hand raise button. Okay, let's see how you did on these. All right, so to undo something with a square root, all right, we're going to square both sides. And so the square root and the square will cancel out, and that'll just leave us with x equals 49. All right, that's the only thing. That's your only answer there. And then remember, you can always go back and, check them by putting them back into the original, right? Okay, what about part B on this one, right? So the bases are not the same here, but we can make them look the same. And so if you can make those bases look the same, right, like we talked about up here, exponential with like bases. So we can make it look like that because 2 to the third power is 8, right? So I could change this to be, so that'd be 2 to the x equals 2 to the third, right? So that means that x must equal 3 on that. Okay, so on this last one, all right, I want you to put into the chat box what you came up with for an answer on that. Don't click enter quite yet. Put your answers in. What did you get for part C?
Sorry, question. Well, how did you get the 3 for part B?
For part B? So do you see how we got the 2 to the third power? So, and maybe another way that you could look at it is if you take that number, that 8, and you did the prime factorization of that number, well, we know 2 times 4 is 8, and then 4 breaks down to 2 times 2. So 2 times 2 times 2 is that's where we're getting that 2 to the third power. And then remember, when they're like bases, right, when these guys are the same, then you just set that exponent equal to each other.
Oh, that makes sense. Thank you.
You're welcome. No, thank you for asking. Let me make sure this is clear. Okay. So remember on this one, we'll do 2 to this power equals this. All right, that's what you should have done. All right, so everybody have that into their chat box. 3, 2, 1, hit enter. Let me see what you came up with. Nice. You guys are doing amazing. All right, so 2 to the fourth power equals x, and then you just had to simplify this. 2 times 2 times 2 times 2 is 16. So x equals 16. Right? That's what it looks like most of you came up with. Isn't math so awesome? Look at this. You guys are doing amazing. Okay. All right, let's turn to the next page and let's take a look at some of these. So again, sometimes, students look at this first question and get a little overwhelmed and they're like, oh no, there's a lot more to it. But I want you to just kind of break it down a little bit and be like, okay, what kind of a question is this? Well, I see that it's a squared, right? And so if I go back up and look at my chart here, I'm like, okay, it kind of looks like this. It's quadratic, but there's just more stuff around it, right? So before I can take the square root of both sides, I need to get that other stuff, right, that isn't just squared, over to the other side. Okay, so let me come back down here again. What happened? Okay. So it's a quadratic. We're looking to try and square root both sides, but we cannot do that first, right? I need to move the other parts over first. So just like when we do, if I had like 2x plus 3 equals 5, right, in this, you would say, yeah, I'm going to subtract 3 over, and then I'll divide by 2. Same thing happens here. You're going to subtract the 7 over, and then divide by 2. All right, so don't let all of the other stuff in there kind of like freak you out. Just be like, okay, what am I trying to do? How do I get this by itself? All right, so let's start by subtracting 7 over. So that will give me 2 times x minus 5 all squared equals 2. Right, the 9 minus 7. And now I have 2 times this, so to undo that, let's divide both sides by 2. Right. And that will give me x minus 5 all squared equals 1. Right, I just kind of simplified these here. Let's see, 2 divided by 2, 2 divided by 2 is 1 there. All right, and now we're to the point where we could do what we did above, right? We have our squared part by itself, so now let's take the square root of both sides. Right, so here, that square and the square root undo each other, so I'm left with x minus 5 equals, now not just the square root of 1, but remember plus or minus the square root of 1. Right, when I'm taking that square root here, when I'm solving for x, remember I don't know whether it's going to be a positive or a negative, because think of something simpler, right? If I had x squared like this equals 16, right? Well, that could be negative 4 squared is 16, or positive 4 squared equals 16. Okay, so that's why we have to do this plus or minus business. Okay? And then we'll add the 5 over to get x by itself. So x equals 5 plus or minus the, well, sorry, the square root of 1 is just 1. So let's just write it down that way. We don't really need the square root there anymore. And that will help us simplify this more too. All right, so we have x equals 5 plus or minus 1. So remember, this is 2 different answers. This is x equals 5 plus 1 is 6, and 5 minus 1, which is 4. All right, so 6 and 4 would be my answers on those two, or for that question, right? And we expect that there's going to be 2 answers because remember, our highest exponent was a 2. And so that's telling us how many solutions we'll end up with there. If it was a 3, we'd expect 3 answers. If it was an exponent of 4, I'd expect 4 answers, and so on. Okay. What about anything I can clarify there on that one? Okay, well now it's your turn again. Okay, so I want you to try these 3, right? So A, B, and C, and then it's the next part, and even though there's other stuff around, right, what you just did on those last 3, right, I want you to see how they're really similar to each other and how you're trying to get those parts by itself so that you can solve it. So just ask yourself, right, how do I need to undo the connection that is there? What do I need to do first? Okay, so let me give you a few minutes. I want you to work on those A, B, and C, and please feel free to, either type something in the chat or, unmute yourself and ask, some of you are like, I'm thinking about doing this first, but I'm not quite sure. Just get some feedback from other people like you would if we were in class. Okay, go ahead and click your hand raise button to put it down. Some of you still have your hands up. I see Braxton and Caitlin. You still have your hands up. If you'll put your hands down. And then when you finish that first one, I want you to raise your hand again. Okay, so let's just work on part A. Let's do these kind of one at a time. But keep going. If you get A done, go ahead and do part B. All right, but just raise your hand when you have part A done.
do have a question about the logarithm.
Yeah.
So with the example one, you didn't put log of x plus 3. So does the exponent not need to get the log part put in, or is it just that coefficient part?
So in the log one, you've got to move that 2 over first, right? So you'll add the 2 over.
For B, the one where you put it into log form.
Yeah. So you'll move the 9 over first.
Yeah.
And then you'll take the log. Well, actually, on this one, it works out to be, you don't have to take the log. You could make the x, or the bases, be the same.
Okay.
Do you want to try it that way?
Yeah, but with the example one.
Let me look and see which one.
The one with the exponential with unlike bases.
Uh-huh.
So you didn't put log x plus 3, you just put x plus 3 and then log of 2.
Right.
So do you not do log with the exponent?
No. So the whole thing, the reason why we're taking the log here is because there's a property of logs that say that we can take whatever the exponent is on the log and bring that down in front to multiply by it. So we don't take the log of that one. Good question. All right, so we're just taking the log of 2. Thank you for clarifying that. I was trying to figure out where you were talking about. Thank you. All right, let's look at part A together. I'll give you a little bit more time. Some of you probably aren't done with C yet, and that's okay. But let's look at part A together. Braxton, would you mind telling us what you did first to try and solve this and help us work through it? Just part A. Don't hear you, Braxton. You unmuted yourself, but... Weird. I don't know why it's not working. Do you have some kind of a mute on your microphone? Are you using any headphones? If there's a mute on the headphones, then it won't pick up. All right, well, hopefully. Well, type in the chat, Braxton. What's the first thing that you did? All right, so you subtracted 4 first, all right, which is a great place to start because remember, all right, we're trying to get the square root part by itself. So when we do that, we'll have the square root of x minus 3 equals 20 minus 4, which is 16. All right, and now, what do we do to solve for x? What would be next? Okay, square both sides. Awesome. So square this side, square this side. All right, so that means our square root and our square undo each other. And so that gives me x minus 3 equals 16 squared, which is 256. And then last thing to do would just be add that 3 over. All right, so x equals 259 on that. Okay. Awesome. Thank you for that. I don't know why your mic isn't working today. That's so weird. All right, how about part B? Haley, would you mind telling us what you did first there?
So for part B, I subtracted the 9 over.
Okay. So then what did you get?
And then I got x to the x, or sorry, 2 to the x minus 3 equals 32.
Okay.
And then I did the log of both sides.
Okay. And you could do the log of both sides here. Let me just show, and we'll do it with the log so you can see that it will work. But this actually will become a common base to this. And remember, if you're not sure, just do the prime factorization, right, of your numbers and see, you know, how they break down. So this is going to be 2 to the 5th power, right? So we could solve it doing 2 to the x minus 3 equals 2 to the 5th. And then all we have to do is set those exponents equal to each other, right? But let me show you, like with the log, it still will work doing this. So I want to make sure everybody understands, like you can still do the log of both sides here, right? Because logs undo exponentials. So that means that I get that x minus 3 out in front, right? Because all of this power, the exponent is coming out in front, and then times the log of 2, right, equals the log of 32. Right? And then when you divide by log of 2, right, so what's log of 32 divided by log of 2? It should just be 5 because it's going to be that same as that exponent now. So at this point, it becomes the same. All right, so then you should get x minus 3 equals the log of 32 divided by the log of 2 is going to be just 5. And then we can add the 3 over. Right? So x equals 8 on this one. Okay, and same thing over here. Add the 3 over. So x equals 8. All right, so either way is going to totally work. So I'm glad you brought up that, you know, you solved this by taking the log of both sides, right? Because that is a great way to solve it. It's going to take a little bit longer, you know, maybe, you know, here, but that's okay, right? It still will get you there. So that's what's important. Okay. All right, let's look at...
I have a question, Becky.
Yeah, of course.
In my calculator, like how am I inputting log 32 divided by log 2? Is it like,
so
I know there's a little button, but...
Yeah, I would do log of 32 equals, so figure out what that equals, and then divided by log of 2 equals.
Okay, got it.
That will work on all calculators. Some calculators you don't have to take that separate step, but that will work on all of them. So
okay, thanks.
Okay, you're welcome. Thanks for asking. Okay, what about this last one here? Okay, so let's look at this one. Right, so somebody just type into your chat, what is the first thing that you would do to try and solve this part C? What are we going to do first? Okay, add the 2 over. Somebody agreeing with that? All right, we want to get the log part by itself. So let's add that 2 over. So I get log base 2 of x minus 3 equals 6. All right, and now that it's in this log form, this is where I can now change it to exponential form. And this is where, like I said, a lot of people get stuck here and thinking, okay, what do I do now? I'm not sure what to do with this log because logs are fairly new for for most students. So they're like, I'm not quite sure what to do. So just always in your mind think, okay, logs and exponentials undo each other. So how could I get it to that exponential form? Because oftentimes that's going to be the easier way to look at these. All right, so I get 2 to the 6th power equals x minus 3. 2 to the 6th power is 64 equals x minus 3. And then I just need to add my 3 over. So should get 67 on that one, right? X equals 67. Okay. All right, any questions on those? Raise your hand if you're feeling like you're kind of getting the idea here. Well, actually, maybe even better. Well, okay, keep raising your hand. Let's see. All right, so if we're breaking these down, right, you can kind of see, yeah, it's really similar to what we've been doing before, but you've just got to understand how to undo those operations. So hopefully, right, I would say, you know, on your final, since you get to use your notes and your book and stuff, this might come in really handy, this little chart here, right, which is kind of helping you know, okay, if I have an exponential with like bases, or if I can make them like, this is what I'm going to do. If I have a logarithm, this is what I'm going to do. Okay. All right, let's move on to the next page then. Let's look through a few more of these. Done. Oh, it keeps like disappearing, reappearing. Not sure what's going on here. Okay. So let's see, we've done some already like that. I'm going to skip over some of these, but it would be a good idea for you to like go back and try and, you know, work on some of them, make sure that you know how to do them. But let's do part C, because this is one that looks maybe a little bit different from stuff that we've done already. Okay, but just taking a look at it, right? Will somebody just let me know, what do you think would be a good first step on this? What would I want to do first here to try and solve part C? Right, part C. Okay, Casey says subtract 1. I like that idea. I think that's a great idea. Let's start there, right? So let's subtract 1 from both sides. That will give me 2 times 5 to the 3x minus 2 power equals 50. Okay, then what do I need to do at this point? So I see a lot of people saying do 2 times 5. Okay, you guys think about that. Log. So let me point out something for you here, and let's just see. I'm glad you guys said that, because this is a common mistake, and it was actually a common mistake that I forget happens a lot. So I'm so glad you brought this up. So notice that we can't do 2 times 5 because we don't really have 2 times 5. We have 2 to the 5 times something power, and we don't know what that exponent is yet. So remember, like with order of operations, we'd have to do the exponent before we could do multiplication. The problem is here is we can't do the exponent because we don't know what x is, right? So we want to try and get that, you know, the 5 to this power by itself so that I'd be able to solve for that exponent, right? So Casey's saying divide by 2. So everybody see why that would be a good next step? on this because now, right, I have that 5 to the power by itself. Okay, and look back up at your chart. Again, I don't want to go back up again just because it kind of keeps freaking out on me when I do. Doesn't like me moving that quickly, I guess, on there. But we had something, you know, like either the one with the unlike bases or the like bases. Let's get to our next step and then maybe you'll be able to see. All right, so we have 5 to the 3x minus 2 power equals 50 divided by 2 is 25. Okay, now these bases are not the same, but can I make them the same? Right? How could I rewrite 25 so it has a base of 5? Yeah, 5 to the second power. Okay, awesome. Thanks, guys. And so now that my bases are the same, right, it'll be fastest just to set those exponent parts equal to each other. So I'll have 3x minus 2 equals 2. Let's add the 2 over. So we get 3x equals 4, and then divide by 3. Okay, so x is going to equal 4/3 on this one. Okay. Okay, is everybody with me understanding why we needed to divide here rather than do the multiplication? I'm going to actually write that out here so we remember on the step we needed to divide by 2.
So basically, when you divided by 2, when you did the 2x minus 2 equals 2, you just dropped the 5s?
Say that one more time.
So on the step where, okay, so you said, I'm just gonna, the 3x minus 2 equals 2. So did you just drop the 5s?
Yeah.
Because it was, okay.
Because they were like bases. If
Okay.
we had a 5 as a base over here and we had like an 8 as a base over here, then we wouldn't be able to do that.
Okay.
But when we have like bases, yep, we just get rid of them and then all we have left are those exponents.
Perfect. Thank you.
Okay, yeah.
How would we solve it if there was a different basis?
So when it's different bases, remember that's when you have to take the log of both sides. So you could have taken the log of both sides here. So maybe at this point right here, maybe you just didn't notice, or were just kind of in the mode and you were like, oh, 5 and 25 aren't the same, so I'm going to take the log of both sides. And you totally could have done that, kind of like we did. I showed up on that last one here. Remember how here we could have taken the log of both sides, or we could have solved them. But if you can't make them into like bases, then you have to take the log of both sides. So look at in that chart, right, that we did on page 164, where the exponential with unlike bases, right? So you must take the log of both sides. That's the only way you're going to be able to solve those. Okay. I think we have another one coming up here that we can practice on as well. Okay, so let's scroll down. Like I said, I'm going to skip over some of these because some of them are kind of repetitive. I'd really think it'd be a good idea if you went back and tried to work through them and stuff too, and even, on the break or whatever that I give you, if you have a little bit of extra time to try and work through some of those to see if you have any questions, that would be great. Okay, but let's do part A here. All right, so this one, let's do part A. So again, you see how I'm trying to get that exponent part by itself, because what I'm trying to solve for is in the exponent, right? And I cannot solve it with how it is right now. So I'm going to get that part by itself. So that means I'd want to subtract the 4 over first. All right, trying to get that alone. So I got 3 to the x minus 6 power equals 30. Okay, so now you're trying to ask yourself, okay, can I change this 30 to a 3 to the something power? Well, do, like you said, a little prime factorization to check and see. Well, 3 times 10 is 30. 10 breaks down to 2 times 5. Nope, I don't have, you know, like I'd have to have these all be 3s, right? 3 to the what power? Well, they're not all 3s. So that means I can't make these like bases. So I have to take the log of both sides. Let me move this 30 over just a little so when I write in my log here, it'll be a little bit easier to see, right? So I'm going to take the log of this side, and I'm going to take the log of this side. And the whole purpose for taking the log, right, is that now I can take that exponent, let me just circle it here, right? So this exponent can now come down in front. That only works with logs. I cannot do that with any other things. It's a special property of log, right? But now it gets it down to that multiplication part, which will be easier for me to solve for. I can't solve for it when it's just stuck in that exponent spot. Okay, so let's rewrite this and see. So I've got that x minus 6, right, that's out and comes out in front. It's going to times by the log of 3, right, and then equals the log of 30. Okay, let me make sure, like, what questions do you have at this point? Remember, if you have a question, somebody else in the class definitely has the same question, so please ask. All right, well, I want you to type in the chat then, what would we do next? Don't hit enter quite yet. I want to know what everybody's thinking here. All right, so what would we do next to try and solve this for x? Type in the chat what you think you would do next. And again, you can always send the message to me privately, right? You don't have to send it to the whole class. If it make you feel a little bit better just to send it to me, that is totally fine. Okay, everybody have their answers in there? What are we going to do next? Okay, 3, 2, 1, hit enter. Awesome. Okay, so remember, yeah, we're dividing not just by 3, but by log 3. Right? And remember, log 3 is, that's an operation that we're doing to the 3. Right? So let's do that. So let's divide both sides. All right, because then that gets rid of it on this side, and that's getting us closer to getting x by itself. Okay, so then we have x minus 6, that's all that's left on the left-hand side, equals log of 30 divided by log of 3. Okay, so now I want you to put in your calculator, do log of 30 divided by log of 3. Okay. Again, on this one, we'll round it to the nearest tenth again, right? And if you're not sure exactly how to put it into your calculator, you can always do the log of 30, hit enter, do the log of 3, or divided by the log of 3, hit enter. All right, but like I said, other calculators, you can put it in differently. But you should have got something like 3.0959, blah, 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 right? Okay, yeah, a lot of people are saying 3.1. All right, but don't round it yet, okay? I mean, you can say that's what it's, but I need you to keep that long answer in your calculator, right? So if you already cleared that out, do it again. Do log of 30 divided by log of 3. Keep that long number in there, right? Because you won't round until the very last step. And so after we get that into the calculator, then we're going to add 6 to both sides. Okay. And now let's round it to the nearest tenth. Okay. Yep, awesome. Guys are saying 9.1. That looks great. Okay, so it really is just breaking things down little by little, step by step. What do I need to do to get x by itself? Okay, what do I need to do? Oh yeah, Braxton, you got this. Right? Okay, let's try B and C. Let me give you a couple of minutes. Again, it just kind of helps you to know where you're getting stuck, what you know, what you need more help with if you have to work through it step by step. Okay, so let me give you just a couple minutes. When you get done with those two, you can get up and take a little break or something like that too. Okay, because it's about that time. But try and work through B and C first. And get up and take a little break. And we can see, okay, so first I subtracted that 5 over, then I divided by 3, right? Now I want to look and see, can I get this so that my bases are the same? And I can, because remember 8 is 2 times 2 times 2. So I could rewrite this as 2 to the x power equals 2 to the 3rd power. And now that my bases are the same, I set my exponents equal to each other. So x equals 3 on that one. Okay. Now on this other one, right, you can see we've got a log, but make sure you remember if there's no base written on that log, then it's really base 10. And sometimes people want to put that 10 in there just to remind them. But the log is not by itself yet. Remember, it's connected to this 2 by multiplication. So the first thing I'm going to do here is I'm going to divide both sides by 2. So I can get that log part by itself. Okay. And then when I write it down, this next time I'm going to put that base 10 in there to help me remember that I've got log base 10 of 5 minus x equals 4. Right? Whenever it doesn't show you what that base is, that's called the common log, which is going to always be in base 10. And so now let's change it to exponential form because that's how we solve logs. So 10 to the 4th power equals all of this. Right? So 10 to the 4th equals 5 minus x. Well, 10 to the fourth, right, since it's powers of 10, that's just saying that we're multiplying 10 4 times, which would end up being 10,000 on that. Equals 5 minus x. And then I want to subtract my 5 over. Right, so I get 9,995 equals negative x. X is still not by itself yet, right? I need to make sure that I divide it both sides by negative 1. So x equals negative 9995 for that one. Okay. How did you guys do on that? Questions that I can answer there on either of those?
I have a question. So when we did like those log examples, we just took like the power of it, I guess. Why didn't we do that? Why did we do the log 10 instead of doing like 2 to the 8th or something like that? Like we did in the...
All of the other ones always had a log base on them already. So remember, if they started off with a log in them, do you see how on this one it has a base of 2? So when we started with that log, right, we had to first get the log by itself and then change it to exponent form. So 2 to the 6th power equals this.
Okay, I see that difference. Okay, thank you.
Yeah, no, and so if it doesn't have that base there, then you got to put that 10 in and say, okay, this has a base. It's just like it's just an invisible base. They just kind of assume if there's no base written there, because we work in base 10. That's the what we do our math in and stuff. So it's probably why, but I know it seems kind of weird.
I also just read it as like log 2 instead of having the 2 like in front of the log, so I just misread that.
Okay, I'm glad you said that. Yeah, so it's easy to kind of think of it. So you were thinking 2 to the 8th power equals that?
Yeah.
I see what you're meaning now. Okay, awesome. Yeah, and I bet you're not alone. I bet other people did that as well, because with that log base missing, your mind just tries to fill in the pieces and stuff. So that might be, really helpful to a lot of people. Thank you.
Thank you.
Okay. All right, well, we're going to switch gears a little bit now. So we've been talking about so far all of these solving of these different types of equations that we've talked about this semester, right? And so now we're going to kind of go and review over some graphing that we've talked about this semester. And so this first part here, we're just going to be making little rough sketches of what these different types of graphs look like. So every graph, like, when they have certain properties to them, are going to look the same way, right? And so, and you'll talk more about these in 1050 also. Sometimes they call them parent functions or mother functions or something like that, because you think about, if it's, the name kind of came from because, kids, oftentimes have the same characteristics as their parents. And so it's kind of like, all right, they look similar, but they're not the same, but they have a lot of the same characteristics to them. Okay, but let's talk about, so let me just draw in some little XY coordinate things here, first of all. All right, and again, I'm just going to be, this one I'm going to do 2 different ones. Oh no, wait a minute, it's already in there. Just joking. Exponential, I'm going to draw 2 different pictures in there, right? 2 different graphs, and also on logs. I'm drawing these in first of all, because we want to kind of think about the general shape of these, right? What a rough sketch of these different type might look like. Okay. Actually, on quadratic, I'm going to do two different ones also. Do it here too. Okay, so when we're talking about this first one with the linear, right? Remember we said, you know, lines, right? If it's a linear function, it's always going to have some kind of, you know, a constant rate of change. And so it's either going to be always increasing, or you could have one going the other direction that's decreasing, right? But these are linear, right? With the linear where the slope is 0, remember when slope is 0, that means that it's not going up or down, it's just staying level. And so that would be something that looks like this. Okay? Just some kind of horizontal line on your grid. Right? Where an undefined slope is going to be a vertical line. Right? If you want to remind yourself, right, slope 0, horizontal line, slope is undefined, vertical line, maybe write those words out to the side too. Okay, but those are all our different ones that we came across with linear functions. Right? But now with exponential functions, remember that we talked about, we've got exponential growth, and we also have exponential decay. And even though these have the same look to them, I just want to really, you know, reiterate kind of what these look like, right? So with exponential growth, remember, it's going to be getting really, really close to the x-axis here. And it's growing as it's going from left to right. So it's kind of doing something like this, right? But we have an asymptote. So let me write, just draw a little dotted line here so you can see, right, as you go further and further negative, right, that's going to get closer and closer to the x-axis. Okay, so this dotted line that I put on any of these is just meaning the asymptote. That's where the asymptote is. Okay, with decay, right, remember it's starting off really, you know, with a lot, and then it's coming down to almost nothing, right? I mean, think about, you know, like that dead deer on the side of the road or something like that, right? It starts off with a lot of mass to it as it decays, right? Oh, poor deer, I know. I swore. What did I say? Did I say mother function? I say that, and you know, sometimes I all right, and I forget, right, that, oh, I shouldn't say that. All right, so if we're going, it's starting here and it's coming down and getting closer and closer. Oh, I said asymptote, huh? That's what I said. Okay, all these swear words in math. What can we say? There's actually a really funny shirt that I really want to get. I'll pull it up when I give you guys a little bit of time to work here, because it's hilarious. And now you'll understand why it's so funny. At least I hope so. Okay, so exponential decay looks like this. But notice with exponential functions, right? Our asymptote is always going to be a horizontal line. It doesn't necessarily have to be the x-axis. It could be something different, and that's what we're going to kind of talk about here in a few minutes, is we'll see some graphs where it's not the x-axis. So far, all we've dealt with are ones that have the x-axis. Okay, but then with log graphs, right? So let's look at log graphs. Well, let's see. So with log graphs, I also have logarithmic growth. So that's going to be my first graph here. And then I also have logarithmic decay. right? Now remember, log graphs grow really, really, really slowly, right? They kind of get to a point where they almost look like they level out. They don't, but they start growing just so slowly, right? So log growth kind of looks like this. It's going to get really, really close to that y-axis, right? But not touch it. And then it's going to kind of go up and out like this. Okay, but we still, we do have an asymptote here. Okay, there's my asymptote. Okay, with log decay, right, I still am going to have a vertical asymptote. Right, and on this one though, think about, you know, if something is decaying, right, it starts off with more and kind of ends up going down, right? So on like decay, it might look like this, where you're starting here, and then as it's getting closer and closer, in this case, to the y-axis, right, it's headed down. Right, so again, here I've got my asymptote is here. Okay. So hopefully, right? Oh, Braxton. I know, there's always a lot of fun things you can say. Have a lot of fun with math. You got to, right? You got to laugh at it, because some of these words we come across, oh my word, I don't know what they were thinking. All right, with quadratics, remember quadratics are always U-shaped graphs. So make sure that when you're making your quadratic, right, they don't come down at a sharp V. In 1050, you'll talk about graphs that do that. We always want our graphs to kind of be, when they're quadratic, are going to be a U-shaped graph, right? So maybe look like this, okay? Or it could be an upside down one also, right? Like this, okay? So those are both quadratic when they're written this way, okay? And then a square root is going to have a starting point, and then it comes out. Remember that the square root is like half of a sideways parabola, right? We can't have that bottom part because it wouldn't be a function. So when we talked about square root functions, we said we're only going to use either the top part or the bottom part, right? So it could look like this, right? The bottom part of a sideways parabola, right? But notice a lot of times people get the log graphs and the square root graphs mixed up, right? But square root graphs, they're not getting closer and closer. There's no asymptote with a square root graph. It just starts here and goes out. Starts here, goes out, right? It doesn't have an asymptote where it's getting really, really close to a certain line, okay? So that's kind of the biggest difference between those. But the reason why I think people get them confused is because they both are slow moving graphs, right? Look at how it's like going up and out, not going out really fast, okay? All right, we're going to skip the other parts here. We didn't talk about those, and like I said, you will kind of get into these more into 1050, so that's why I kind of skipped it in the book and stuff, so we could just make sure we got to all of the things that were really important to know, okay? All right, so we've talked about how to graph these already, right? And actually on the last test, right, you were supposed to, know how to graph these. And remember, when it's written in this form, we can say, all right, I can see what the vertex is right away, right? My vertex on this is going to be the opposite of what's inside, right? Insiders are liars, so -1, and then the outside stays the same, right? So my vertex is going to be to the left 1, down 3. So there's my vertex. And I can tell it's a right side up parabola because there's no negative out in the front, right, of my parenthesis here. If it was negative there, then I'd know it was going to be an upside down parabola, but I know it's going to be right side up here. Okay, and so we could find maybe just a couple of other points. So we already found the vertex, right, was this -1, 3, which was nice, easy to find. But we also could find the x-intercepts and the y-intercepts. So the y-intercept, right, we let x equal 0 and solve for y. So if we put, right, 0 in place of our x there, 0 plus 1, all squared, minus 3. So 1 squared is 1 minus 3 gives me -2. All right, so here's my y-intercept. So over 0, down 2. Looks like about there. Okay, and right now this does not look like it's a parabola, right? Look at that, it almost looks like it's a straight line. So we've got to plot some more points. So let's do our x-intercepts now. Right? And sometimes with our x-intercepts, you'll either need to use the square root property to solve this for x, just like we were doing in the last few, right? Or you might have to use the quadratic function or something like that. Okay, but with the form that it's in, it's going to be easiest for us if we just solve it. So we're going to let y equal 0 this time. So we'll have 0 equals x plus 1 all squared minus 3. Right, we got to get this 3 over to the other side. Remember, we're trying to square root that, but we can't square root that part until the squared part is by itself. Right. Different color here to show, okay, now we're going to square root both sides. And so that gives me not just square root of 3, but remember now that's plus or minus the square root of 3 equals x plus 1. Right, that's square root and square. Cancel each other out, and now we just need to subtract that 1 over. And we'll put it out in front of that plus or minus sign. So we've got -1 plus or minus square root of 3 is what x equals. And we'll just leave it. Well, actually, I guess when we're trying to figure out where it's at on here, that's not very helpful. So let's find some decimal approximations. All right, just round them to the nearest tenth. We don't need to go out too far because this isn't a super precise graph. All right, but if I do that and I get so 0.7, right, and the other one's going to be -2.7. So 0.7 is going to be about here, and -2.7, you're about there. Okay, now it's a little bit easier to see that shape of the parabola. Again, make sure that you're kind of making the bottom of it look U-shaped, okay, not coming down at a V. Okay, hopefully that's, so you're kind of following all of those things that we did there, right, with this type of graph. And this is a quadratic, right, so graphing quadratics, right, we like having it in this vertex form. We can easily see where the vertex is. And we could have even just made a rough sketch of what it would look like, knowing where the vertex is and knowing it goes up. Okay, but we wanted to find at least 3 points on there. Whoops, I didn't put these in here. So remember we had 2 x-intercepts. Right, we've got the 0.7 comma 0, and we had the -2.7 comma 0. Okay. All right, so hopefully that first one you're like, okay, yes, just did those, feeling comfortable with them, I know how to do those. Okay. But let's look at some other shapes of graphs. Maybe, just going to skip over to the next page here. So maybe, is it 170 or 171? Try and find this. I just skipped one page there. But this time I want to graph this function. All right, Haley says it's 170. All right, where it says the square root of 3 minus x and then minus 2. There. All right, so this is a square root graph. All right, so we know, if we go back up here, remember this is going to be kind of come in handy for you to look back on. Hopefully I can do this without it getting freaking out too much. So we know it's going to look something like this. It doesn't have to start at the origin like I did on these, and you'll see that in the other when we're doing a few examples here, right, how they look a little bit different. Okay, but they still have the same characteristics to them. Okay, they mostly look the same. All right, so first thing it asks us to do is we've got to figure out what the domain is. Because remember with square roots, I'm going to write this over here, right, that we can only find the square roots of positive numbers, right, in the real number system. If we have negatives of square roots, then that goes into the negative, or the imaginary numbers, and that's not what we're plotting here, right? This is real numbers that we're plotting on our graph here. So remember that inside the square root must be positive numbers. Let's just say it that way. So that's what we're going to find here with the domain. So when you're trying to find the domain of something like this, you're going to set that inside part, so just the 3 minus x. We don't care about that negative 2 or that minus 2 because notice that part's not under the square root. Okay, we just care about the stuff that's under the square root. So we're going to take whatever that is, and I want to solve it and figure out where x would be greater than or equal to 0. Right? I want to know, because remember, anything that's greater than 0 are positive numbers. Right? So maybe right over here, right, in order to do this, you're going to set the inside of square root greater than or equal to 0. Right? And so when I solve this now, right, I want to keep my x on the left-hand side. It's just easier to read inequalities that way. So I'm going to choose to subtract my 3 over. So I get negative x is greater than or equal to negative 3. But when you divide by a negative with inequalities, remember it flips that inequality sign the other direction. So we really have x is less than or equal to positive 3. All right, well, let's think about this on a number line. What am I talking about with my x's? Well, here's 3, and I want the stuff that's less than or equal to 3. So I've got, here's 3, and I want all of the stuff to the left, because that's all the stuff that's less than or equal to it. Right? And so we'll write our domains in interval notation. Remember, we did this at the very beginning of the semester, like within the first couple of weeks at least. Right? It's when we were talking a lot about this domain and range stuff. Okay? So it might be that you're like, oh, okay, trying to remember, right? So the domain is going to be, so you're reading the graph from left to right, so it's going clear out to negative infinity, so parenthesis negative infinity to 3, right? And it stops there, right? We only want to choose x's that are smaller or equal to 3. So I'll say 3, and because it equals it, I'm going to use a bracket, not a parenthesis, on that 3 side. And that would be my domain of this. Okay, what questions do you have on that with the domain? Anything there? Okay, let's look at, so we're going to graph this, right? So we need to choose numbers that are 3, right, or smaller. And usually you want to start with that 3, okay, whatever number it says it can equal to. And you want to pick numbers that are going to be efficient, ones that are easier, like that have whole number answers to them too. So that will make it a little bit easier. So let's pick 3. So if I pick 3 here and I put 3 inside, right, I've got the square root of 3 minus 3 and then subtract 2 off. Right, 3 minus 3 is 0, square root of 0 is 0, 0 minus 2 is negative 2. All right, so I found a point of 3, negative 2. So over positive 3 down 2. Put a point there. Okay, now let's do some other ones. What about, so remember I got to pick them less than 3. So what about 2? Would 2 be a good one to do? Well, 3 minus 2 is 1. Square root of 1 is 1. So that would be a great one to pick. Okay, so let's do 3 minus 2, square rooted, and then subtract off 2. So square root of 3 minus 2, square root of 1, square root of 1 is 1. 1 minus 2 gives you negative 1. So I'm just plugging those numbers into the function to figure out what my output would be. Right? So positive 2 and then down 1 be there. Okay, now let's keep going. How about if would 1 be a good one to pick? Okay, and this is, I'm trying to help you pick good, numbers for this. Well, 3 minus 1 is going to give you 2, and square root of 2 is not a whole number answer. So we want to kind of pick numbers so that there's going to be, like perfect squares inside there. So what if I did negative 1? Right, if I put negative 1 in there, 3 minus a negative 1 is actually telling you to add it, right? Minusing a negative. And so that would be the square root of 4, and that is a perfect square. Okay, so let's try that one next. So if I do square root of 3 minus a negative 1, right, and then I'll subtract off 2. So remember I'm doing the square root of 4 minus 2, right, which gives me 2 minus 2, which gives me 0. So negative 1 comma 0. So over negative 1, 0 would be there. Okay, so I can kind of see the shape of my graph coming, starting out here. Remember that I said it's either going to, it's going to be doing, that kind of starting at a point and then coming up and out kind of like this, right? This is a very rough sketch of it, right? But that's kind of what this is going to look like. Okay, and so you just want to choose numbers that might be easy to take square roots of. Would be, a good idea. Maybe negative 6 would be another good one to pick. Why would I say that? Well, negative 6, so 3 minus a negative 6 is 3 plus 6, right, which is 9. Square root of 9 is 3. 3 minus 2 is 1. Right, so I'd get over 6 and then up 1. So yeah, you see how my graph is a little bit, whoops. So I get rid of that graph there. So I had negative 6 1. It's going up kind of slowly, right? So great with the marker on this. Okay. All right, but that's what that one's going to look like on there. I'm not going to worry about those, but let's look at this one, okay? And before we maybe look at this, I want to go to Desmos, and I want to just kind of show you some graphs here. Okay, so the one that we're trying to look at is this 4 to the x plus 2 minus 3. All right, let me get rid of these in here. And let's look at some other ones here. So first of all, I want to just do, what does y to the 4, or yeah, y equals 4 to the x power look like? All right, so this is just kind of the regular shape of it. All right, if we had just this 4 to the x power, we didn't have that plus 2 or that minus 3. So now what I want to do is kind of show you what that plus 2 and the minus 3 does to this. Okay, so on the next one, I'm going to say, okay, well, what does y equals 4 to the x plus 2 power look like? Oops, didn't keep it as a x plus 2. Why is it doing it? Oh, let me put it in parentheses. I think it doesn't like it because it's not in parentheses. Okay. Heavens. Okay, so we're looking at this going, all right, well, what happened here, right? And the easiest part of the graph to kind of compare with one another is, well, in the first graph, it's the y-intercept there. But do you see how that y-intercept was now moved 2 places to the left? Okay, and so it's actually good that I put it inside parentheses here, because remember when we said like insiders or liars? So it's inside these parentheses, and so it's moving it, right? It's moving the whole graph 2 places to the left, is what that's doing. Okay, now let's look at what happens, what is that -3, that minus 3 doing? So let's look at what if it said y equals 4 to the x power, but then I'm just going to minus 3. Okay, so I'm comparing it all, you know, to this red graph, or pink graph is what it looks here. All right, so the blue one, right, moved 2 places to the left, but look at this one. Right, again, if I try and compare where my y-intercept is, it was here, and then it moved 1, 2, down 3 places, right, from where it was. All right, and now look at that, moved my asymptote also. So now it's getting really, really close to -3. So this -3 on here, if it's like subtracting off 3 there, that's moving that down, which moves your asymptote down to that line y equals 3. Okay, so those are kind of, you know, just different, you know, so you can kind of see how those relate together. But I'm going to just write in here, just to kind of help you remember here, that this is moving it down three places, where this other part here, right, that part that was in the exponent is moving it to the left 2 places. Oh, what's happening here? It's freaking out on me. Okay, so there's different meaning that comes from this, right? And also, all right, that -3 is where my asymptote is going to be. So I'm going to go ahead and draw that asymptote in here, right? Moved it down 3 places, so the asymptote is now, it's not on the x-axis anymore, right? It's shifted down 3 places, so now it's at that line y equals -3. All right, still a horizontal line, but shifted down 3 places is where that asymptote is, and that's what that -3 is showing you. Okay, and again, if you were kind of, you know, trying to do a rough sketch of it, remember that our, you know, it started off like our regular graph would go through this point, right? But this is telling me how those are moving. So it's saying basically that this point is going to go left 2 places and down 3. So what used to be here has now moved to down here. Okay? And then it's going to be a graph that kind of, you know, goes through that point. And you could put in some, you know, some places or, you know, different x values, figure out the y's like we did on the other one. And maybe we'll do just a couple of them here. What if we do, let's do an x equals -2. So we always want to know, like, what happens when this is a 0, right? -2 plus 2, that makes that a 0. So that would be 4 to the 0 power minus 3. Well, 4 to the 0 is just 1. Anything to the 0 power is 1. Minus 3 gives me -2. So, right, and so do you see that that's where this point is that I just came up with now? Right, went over 2, down 2. And that's where I ended up with this point. Okay, and then let's try just doing a couple more on there. What if I put -1 in? So 4 to the -1 plus 2 power, then minus 3 after that. So 4 to the first power, that's what that simplifies to be, and then minus 3. 4 minus 3 is 1. So -1, right, and up 1. Okay, remember this, I'm going to cross through that point because that's the old one. That's where it would have been, but it's not going through that point anymore. Right? And then maybe we'll just do 0 also. Let's do one more here. So 4 to the 0 plus 2 power, and then minus 3. So that's 4 to the second power, which is 16. Minus 3 gives us 13. Well, and that's going to kind of go off the grid here. All right, let's label it up here that this is 0, 13. If that kept going. So do you see how it's kind of getting really, really close to this one? It's going up. Right, and then it's going to go through. Oops. All right, it's not such a great job there, but it's going to look something like that. Okay, but now my asymptote is that y equals -3. Okay, but the last thing I want to talk about on this graph is I again want to make sure you know how to find the domain and range of any graph. Right? Remember the domain, you're looking at it from left to right. So that's going to be from -infinity, and then it's going up and out forever, so to +infinity. And the range you're looking at from bottom to top. So the furthest down it goes is -3, but it doesn't ever touch -3 because that's an asymptote. So I'd have -3, and then it's going to go clear up to infinity. Right? So those would be my domain and range on a graph. Okay, something like this. Okay, what questions can I answer on that? So really with graphing, you can always just pick any x, plug it in, figure out what the y is going to be to plot some points and see what the shape is going to look like. Okay. Yes, did somebody have a question I can answer?
Becky, on the first one, like the 4 to the 0, where's the 0 coming from? Like when you have the -2?
Oh, wait a minute. What did I do there? Oh, yeah. Because I just put it into, sorry, I didn't do the full thing. So 4 to the 2, -2 plus 2 power, right? So I put -2 in there. Yeah.
Gotcha.
Yep, that's where I got that from. Sorry, yep. All right. Yep, so just plug it in, and sometimes you'll just have to just do a little bit of work out to the side to see what those come out to be. Okay. All right, the other thing that I'd like you to look at, and we're not going to have a lot of time here in class to do it, but it's Lab 14, and it's in your modules, but I'm not going to have you do it for homework, but I do have it in there. I'll post the key also so that you can try and work through some of those, but there's some of them that we didn't ever talk about in class, and so that's why I didn't want to have you guys have to worry about doing it, but it gives a lot of really good review that we've talked about this year, so maybe we'll get to some of it, you know, more next time in class a little bit, because next time we are going to be reviewing for the final, and so this kind of is going to review through some of those things, but there's going to be parts that you don't have to do. Maybe what I'll do, I'll go back through and I'll kind of X out the ones that you don't have to do on there, so you're not like going, oh, wait a minute, should I know this? Because like I said, there's a few types of functions, remember that I said we didn't talk about this semester, that's going to be in this lab, and so I'll go back through there. But it's going to just kind of take you back and think about some of the things that we talked about, you know, at the beginning of the semester, all these different types of functions that we were dealing with, right? So remember, when you were given a table of values like this, you can, you know, try and figure out, well, what's happening here, right? As I'm going, you know, from 0.12 to 0.6. Well, that might be harder to see. If I skip down here further, well, going from 3 to 15 or 15 to 75, I can see, oh, I'm multiplying by 5 both times there. And that's actually what I'm doing, you know, on all of them. And so when I'm multiplying by 5 each time, that means it's an exponential graph, right? And so, and then it's going to, you know, like have you write things as, you know, what is the algebraic rule for it, which just as a fancy way is how do you write an equation for this, okay? So, yeah, maybe I'll just use a little bit of time at the beginning of class next time to go through some of these, because it will be a great review of things that you need to make sure that you know for the test. And then also next time we're going to be going through some other review questions and stuff, and I will post, there is a review on there already, but I might post another one that will be kind of helpful if you're like, okay, I'm going to want to know how to do a few more types of problems, okay? But as far as the final goes, so it is going to be open book, open note, just like your last test was, okay, the exam 3. But remember, it's not open to other people, right? But use your personal notes and stuff like that to help you with this. And they just said yesterday, and I'm not sure exactly how they're going to split this up for sure, but it sounds like the math department wants to allow 3 hours for the exam rather than 2, not because they feel like the students will need the 3 hours on this, but just because in that time you need to get everything uploaded to Canvas, and sometimes that takes a little while. Sometimes there's a little bit of issues and stuff like that. And there's going to be 2 parts of the test. So one part is going to be Canvas graded. So that'll be a little bit different. And so I think they're going to allow 60 minutes on that one. That's the Canvas graded. And then on the second part, it's going to be kind of like our last test, where it's going to be, you write it out and I'll correct it and give you partial credit according to what you did there. And then you'll have to upload it and stuff in that amount of time. So I think they're saying 2 hours for that second one, not because you'll need that full 2 hours, but because you want to use about 15 minutes or so of it just to get things uploaded and make sure it's in on time. Okay, does that make sense, or is there anything I can kind of clarify for you? I know some of you have been kind of anxious, wondering how this is all going to look and stuff, so I want to make sure you're feeling prepared for what to expect for the final exam.
So for the other half, so half of it's going to be, we're going to do it on Canvas, and then the other half we're going to print and then take a picture and send it to you?
Yes.
Okay.
Yep.
Okay.
So like I said, so that second part, they're just allowing more time on it just to make sure everybody has time to get the uploaded to me.
You don't have to print it, right? Like
Nope.
how I've been submitting it to you, where I've been taking a picture of my notebook and this. Okay,
That's
that works
perfect.
too.
Yep, that
Okay,
works. Yep.
right.
So you either, some people just feel better about printing it out, make sure they get it all down and they have a printer. That's great. You don't have to. You can always just write it down in your notebook on lined paper. Just make sure you keep everything looking neat and easy to read, and that's great. Okay.
Okay, thank you.
You're welcome. All right, guys. I can't believe the semester is almost over, right? We got one more class period, and then, like I said, at the end of class next time, we can kind of decide if you want a little bit more time to review, and then we can find some time on Friday to do a review to make sure that everybody is feeling comfortable with what they need to know for this test, for this final exam. Okay. All right, if you have any individual questions and you want to stay on a few minutes and ask me, that's great. Otherwise, I will see you guys on Thursday. It's going to be a great review, so make sure you don't miss it. I'll be giving you some kind of helpful things, okay? Okay, guys, see ya.
Bye.
Bye. Thanks for being such an awesome class.
Thank you for giving me extra time on the test.
All right, see you guys.
Becky, I actually had a question. So for the rest of the, this week, our homework is just on infinity, the rest of the stuff?
Yep, it's just going to be on infinity.
Okay.
So there's going to be one that you do, let's see. Yeah, so you should have started the 12.1 already. And then there's one that's combined together. That's 13.1 and 13.2.
Okay.
So then when you get those done, you'll be done. Like I said, there's that lab 14. But it's just, it's not something you have to do. It's not going to be something graded, but we'll go through a lot of it in class too next time. At least I'm going to try to go through more of it there. So,
okay. All right.
Okay.
Sounds good.
All
Thank
right.
you.
Yep. We'll see you Thursday. Okay.
Yeah.
Okay.
Thank you.
Bye.